Alrighty, everybody, we are going to be taking a look at a few of the balancing word equations from your balancing practice that I assigned during class. The purpose of this is to take you through how do we balance equations and when we have to formula write on top of balance. So these problems are not necessarily harder, it's just difficult if you haven't mastered the skill of formula writing yet, especially ionic formula writing. So the purpose of this is to take you through a few examples so that we can kind of get well equipped and ready to do this on a quiz and in the future in this class. So in looking at number 1, we're going to do that as our first demo problem. We have copper plus silver nitrate is turning into the products of silver and copper 2 nitrate. What we're going to learn later in the unit for the reactions unit is this is what we call a single replacement reaction. But for right now, I'm going to give you the reactants and the products on either side of this arrow. All we have to do is translate this into chemical symbol form and then balance the equation. So copper, the chemical formula of copper, in case you don't know, is Cu. All right, so we're going to add Cu in to our first thing here. Now the next thing we have to do is translate silver nitrate. So silver is right underneath copper. Okay, silver is the symbol of Ag, and then nitrate ends in this ATE ending here, which means it's probably from the back ion sheet on the periodic table. Okay, so nitrate is, if we look in the sheet, we'll eventually arrive at this formula here, NO3 minus 1. Okay, so I'm just going to write this in as NO3 minus. Now, we also need to know the charge of silver. Silver, the cation, is a transition metal. It's from the middle of the table, so that means that we have to get the charge from the back because there's no direct patterns like we have in our main chemical families. So silver here has a charge of +1. Okay, so when we put this together, luckily for us, we can just go ahead and add a nitrate onto that silver. Okay, so now what we're going to do is we're going to write silver on its own. That's one of our products that we're going to make. And then we are going to go ahead and we are going to write down the formula for copper nitrate. Now at this point, some students might be tempted to write down a charge on the element on its own. Okay, now when an element's on its own, it's actually going to be electrically neutral, so you don't need to write charges next to anything. Silver and nitrate only have charges when they are in the ion form, and when you stick them together, their charge is neutralized to 0. Okay, so whenever you have an element on its own, no charge. Okay, so now copper here, what we're going to do is we are going to look at copper 2. Now a lot of students at this point might be tempted to put down 2 coppers with a nitrate, but what I would ask you is what is the charge of copper 2? Well, if I look it up on my periodic table here, copper 2 has a charge of 2+. So it's not saying that there's necessarily 2 coppers. What it's saying is that there is a copper with a +2 charge. So when we do this, right, we want to balance out the charges so that the charges equal 0. That means that you need 2 nitrates, since each nitrate's -1, and 1 copper to make that overall charge be 0. Okay, so now that we have all of our formulas written, what we can go ahead and do is we can go ahead and balance the chemical equation. So if you're a person who really likes to use that inventory method, great. Okay, so we can kind of write our Ag here and Cu as the 2 atom categories. Now, what I can do here is I'm going to put a box around the NO3s because I can balance those as a group since the polyatomic appears on both sides of the equation exactly the same. And that's going to make our balancing life a whole lot easier here. All right, finally, what we're going to do is we are going to balance the equation using coefficients only after we take our inventory. Okay, so we have 1 and 1 of each metal here. And then we have 1 copper, 1 silver on the right side as well. And then the difference is that we have 2 nitrates on the product side and 1 nitrate on the reactant side. So what we're going to have to do is we're going to have to go ahead and balance out the nitrates first. Okay, so in doing that, since there's 2 over here to the right, what we have to do is we have to add a big coefficient of 2 in front of the silver nitrate. So that's going to turn my nitrates to 2, but in the process of that balancing, I'm going to turn my silvers to 2 as well. Okay, not to worry though, because we can edit that after the fact in post by putting a 2 in front of that lone silver on the product side. So from there, if we check our atom inventory, we are all balanced, and that question is done. Okay? Big key with this is writing the proper formula, right? If you wrote this as copper nitrate with only one nitrate, you wouldn't have gotten the proper equation or reaction going, and that would be incorrect. All right? Next one, barium peroxide goes to barium oxide and oxygen. Okay, so barium peroxide. Again, if you need your periodic table to look up the elements, you can look that up. I know that barium has a formula of Ba, but I am going to look up this peroxide guy because this is a little bit of a weirdo. You probably don't recognize peroxide because usually things that end in "ide" are from the front, but you've probably never worked with that. What a peroxide is it's actually an anion, and it's a 2- ion, and it contains 2 oxygens. Okay, so it kind of is similar to like a hydroxide ending in IDE, just with a -2 charge and with 2 oxygens instead of an O and an H. Okay, so that is going to be our anion that we're pairing up with barium here. And so I'm just going to go ahead and write that down. All right. So there is our peroxide anion. Again, it's a little weird because it ends in "ide", and usually they don't on the back, but that's just a special case. Now barium is from the alkaline earth metal family. Okay, so what that tells me about barium is that has a 2+ charge, and the peroxide, as we know, had that 2- charge. So what that means is as we write this out, we are already balanced. So we just have to add the B, A, and the O together. Okay, now we're going to write down barium oxide. Okay, so this is just going to be our standard barium. And now since this is an oxide, that is our oxygen that we're used to. Okay, so that's going to be an O. Okay, if we check out O on the periodic table, the oxygen family always has a 2- charge. So that's going to cancel the 2+ charge with the barium. Okay, so we'll keep that as is. Now the next thing is we have oxygen. Lots of students are going to go ahead and just write O there. Okay, however, oxygen is one of what we call our diatomic elements. Diatomic elements are called di because di means 2, and atomic means atom. And so these atoms, when they're on their own, always come in pairs. They hate to be lonely. They don't want to be left out. And so the way I help students remember that in class is we look at this creepy clown named Hofbrinkel. Okay, so we call him Hofbrinkel, and there's different names for this depending on your chemistry teacher, because the name Hofbrinkel spells out all the elements that are part of this group that come in pairs of 2. So Hofbrinkel has a little 2 by his hand because all of these elements come in pairs of 2 only when they're on their own. Okay, so these will be coming in pairs of 2 if I just say something like oxygen or hydrogen or fluorine, bromine, iodine, nitrogen, or chlorine. Okay, so since I see oxygen here, I have to add a little 2. Okay, now once we do that, we can go ahead and we can put some coefficients in front to balance this out. All right, so once we have everything written properly. So we just have BA and O at this point. Now to start, I have 1 BA, 2 O's, 1 BA, 3 O's. So to balance this out, I am going to start by looking at my oxygens. So to get my oxygens where I need them to be, this is a little bit of a weird scenario. You may not think that 2 and 3 will work. However, I have a split group of oxygens here to the left, okay, or to the right here. And so what I can do is if I can get this 2 to 4 and double this, right, that will give me 2 bariums. That would mean that I have to put a 2 in front of this barium, okay, and that will also get me to 2. Now by doing that, I've taken this 2 and multiplied it by this 1, all right, giving me a group of 2 oxygens here and another 2 oxygens here. Over here right now, I have 4 oxygens because this 2 multiplies by this 2. So in total, on the right and on the left, I have reached 4 oxygens, so that is my balanced chemical equation. Okay, so there you go. So again, if you only wrote O here, you would have gotten the improper balance and you would have gotten stuck, okay, because you would have a 3 and a 2. So make sure you don't forget your Hofbrinkels or your Brinkelhofs. Depending on who you talk to, you might hear it differently. Okay. Now, one thing I do want to mention before we move on is O only goes in pairs of 2 when it's on its own. Notice that oxygen can exist as a 1 oxygen atom if it's paired with something else. So you only do a diatomic or make it diatomic when it's an element on its own. Okay? All right, the last one we're going to look at here. We are going to look at number 16. Okay, so number 16 is a little spicier, right? And it's a little bit more involved. So let's go ahead and start writing down some formulas. Okay, aluminum is Al, if you look that up on the periodic table, and it's on its own, so it has no charge. We're going to add this to phosphoric acid. Luckily, I'm giving you the acid formulas in this class, so you don't have to memorize how to write those. Okay, and from here, we have aluminum phosphate. Okay, so this is probably where you want to pull out your periodic table and look up the charge of aluminum and phosphate. All right, so I'll take the time to do that now. Aluminum is in the boron family, so this is our +3 column. So that means that this is an aluminum 3+. Phosphate, okay, if I look on the back, phosphate here is going to be a 3- charge. Okay, so if I look this up, here it is. Phosphate, PO4, 3-. Be careful not to pull phosphite instead, because that is a different substance. So we got PO4, 3-. Okay, so now what we have going on is we have a little bit of a different substance being made. All right, so we have aluminum and we have phosphorus here. Okay, so when we have this going on, what we're going to go ahead and do is we're going to pair those two up together. Okay, so luckily this is just a 1 and 1 again. So we got AlPO4. And then we're going to add this to hydrogen. Now hydrogen here is going to have a really, really important thing we have to keep track of. Hydrogen is on its own, so you might be tempted just to write H. However, remember our creepy clown, Hofbrinkel. Hofbrinkel applies to an H, to hydrogen, when it's on its own. So instead of this being just H, this is going to be H2. Okay? Now that we're here, now we can go ahead and do our atom inventory. Okay, so we're going to go Al, we're going to go H, we're going to go PO4. And then we're going to go Al, H, and we can do phosphates because they appear on both sides. All right, so once we have this done, the heavy lifting is kind of over. Okay, we can take our inventory. We got 1, 3, 1. We have 1 aluminum, we have 2 hydrogens, and we have 1 phosphate. So what we're going to go ahead and do is we're going to balance out this equation. Okay. As of right now, the thing that's out of balance and out of whack is hydrogen, so we'll start there. We got a 3 and a 2, so that means we got to get these both to their least common denominator, which is 6. So we're going to go 3 there to get to 6. We're going to go 2 there to get to 6. In the process, we happen to add a phosphate to the reactant side, all right, which might be problematic, but we can fix it after. All right, so since there's 2 phosphates now, we can add a 2 in front of the product side and give us 2 phosphates on that side, and then that also gives us 2 aluminums. So the last thing we have to do is add 2 in front of the aluminums on the reactant side. That gives us 2, 6, and 2 on either side of all those types. Okay, one more problem here we're going to do is we're going to look at this number 14 on your balancing equations practice. The reason we're going to look at this one is because this one has some weird polyatomics going on with it. So let's look up probably first and foremost what ammonium is, because you probably don't know what it is. Ammonium is what we call a polyatomic cation, so it's from the back of the periodic table. Even though it is made of entirely nonmetals, it has a positive charge, so we treat it as if it's part of the metal part of our formula. So ammonium is NH4 and has a +1 charge. Dichromate ends in 8, so we're probably going to find it back here. I've already highlighted it in purple. It is Cr2O7. All right, and that has a 2- charge to it. While we're back here, might as well just kind of look up anything else that we have to look up. I see that there's a lead 2. Lead 2, Roman numeral, means that we have a lead that happens to have a +2 charge. Okay, so lead 2 is Pb2+. It doesn't mean that there's going to be 2 leads in the compound. That's just telling us the charge. Okay, and then chloride, right? Chloride is just chlorine pulled as an ion from the halogen family. So that's going to be a -1 charge. All right, let's take a look at what we do now. What we're going to go ahead and do now is we're going to write out a balanced chemical equation. So what is that going to look like for us? Well, first and foremost, we got ammonium dichromate. So let's go ahead and start with that. So we got NH4. We have to have 2 of them, and the reason I know that we have to have 2 of them is because we have a charge at 2- on the dichromate. So we're going to place a 2 on the outside of the ammonium, and then we're going to go Cr2O7. Okay, now that looks like a weird formula, but the reason we put parentheses there is because otherwise it will look like NH42. All right, so that's our ammonium dichromate with the balanced charge. Lead chloride, so we got Pb. A lot of students will be tempted to say PbCl, but look here, we got a -1 charge and we got a +2 charge. So that means that we have to have 2 chlorines there. Finally, we are going to do the other side. So we're going to make lead dichromate. So we got lead 2 means that the charge is still 2, and dichromate has a -2 charge. So we're just going to put those 2 together. Finally, we got ammonium chloride. So ammonium has a +1 charge, as you remember. Chlorine, as an anion, has a -1 charge. So we're just going to put a chlorine and ammonium together. Now, this looks intimidating, this looks a little spooky, but we'll notice that we have both ammoniums on each side, and we also have dichromates on each side. So that gives us the opportunity to go ahead and group them together in our balancing. So our groups are going to be NH4. We're then going to have Cr2O7, the dichromate is one group, lead, and then we're going to have chlorine. So that's going to make our lives a lot easier now that we have these polyatomics on both sides, so that we're not tracking a million atoms in our balance. Okay, so over here we're going to put that on the product side, and now we're going to start our inventory. So right now we got 2 NH4s, and we have 1 dichromates, we have 1 lead, and 2 chlorines. Now on the right side, we just happen to have 1 of everything. So right now, if I evaluate where I'm at, my ammonium's out of balance, and my dichromate's out of balance. And my chlorine's out of balance. So what we can do here is we can go ahead and balance, starting with like whatever's in the metal position. So whenever we have polyatomics, I typically say balance the cation first. So that means we're going to go ahead and balance ammonium by placing a 2 in front of the ammonium chloride on the product side. That gives us 2 ammoniums and happens to also give us 2 chlorides or 2 chlorine atoms. So that will allow us to go ahead and balance out the equation. So it's just as simple as making sure that we have that 2 there. All right, so that is the last problem. Hopefully that helps. Happy balancing.